Hello, in this video we are going to go over the solution of the problem 778, and to solve this problem the description of the problem is actually not very clear. It's a little confusing, so I'm going to use an analogy to make it more clear what we are going to do. We have already solved a problem which is very similar to this problem, and we are going to use pretty much the same code with a little modification. So that problem is problem 1631 that I put the link underneath of this video, and I highly recommend you to watch that video first and then we come and start solving this problem. So in problem 1631, if you remember, we had cars with different powers. For example, car 3 had a power 3 and could go uphill or downhill for 3 steps. And we were looking to find a car with minimum power that we could move from top left corner to the right bottom corner. In problem 778, in the same way, we are going to move from the top left corner cell to the right bottom cell, and we are going to find a path with minimum required altitude. Imagine instead of cars, now I have flying cars. So for example, flying car 0 has power 0 and can only move on flat surfaces on the ground. Flying car power 3, for example, has power 3 and can fly 3 meters, something like that. And our goal is to find a flying car with minimum power that could perform the job for us. For example, in this matrix, if I select a flying car, for example, with a power 24, I'm good. So I can fly from top left corner to the right bottom corner. But that is a waste of resource. We don't need actually that. If I just select a car with power 16, that is enough for me because I can come here 0, 1, 2, 3, 4, 5, 16 is the maximum. Then I come 15, 14, 13, 12, 11, 10, 9, 8, 7, 6. So I can reach to the destination if I have a flying car with a power of 16. Okay, let's go over the code. On the right side, I have the solution for the problem path with minimum effort using DFS. And on the left side, I have the flying car problem. If you look at the codes, they are pretty much similar. We have the exact same binary search section. Okay, the difference is this. In the previous solution of path with minimum effort, we calculated current difference as the absolute value between the grid of the neighboring cell to the cell itself. But here for our new solution, we are going to use this if statement, and whenever the value of a grid at neighboring node is greater than the value of the grid at the current cell, we are going to update current difference to the neighboring node value here. Otherwise, if the neighboring node value is less or equal, we just put the value of the cell itself in the current difference. So by doing this small modification just in a way that we are calculating the current difference, we should be able to solve this problem. Also, the solution for BFS is also exact same thing as you saw for the path with minimum effort BFS solution. The only difference is again this change that we need to do. And this modification is not gonna change our time complexity or space complexity. Okay, this is the solution of the problem 778. Thank you again for watching this video.